Okay, you guys, so this problem says projection with direction opposite of V. We will get to that at the end. So looking at the directions, it says find the projection of U, which is 4, -3, onto V, which is 2, 6. Then write U as the sum of two orthogonal vectors, one of which is the projection of U onto V. That's very similar to what we did in the last one. I think just our result is going to differ. So based off of that projection, we've got projection of U onto V. It's equivalent to the dot product of U and V over the magnitude of V squared, all times vector V. So what we are doing is we're going to plug these pieces in similar to the last problem. The steps are going to be the same. It's just the end that looks a little different. So we have the dot product of U and V, that's 8 and -18, so that's -10 on the numerator. The denominator, you've got the magnitude of V squared. So if we just find the magnitude of V and then square it, that's 2 squared plus 6 squared, which is 40. We're not taking the square root because it is squaring it at the end. And then we've got that times vector 2, 6. Distribute that. That gives us -20 over 40, which we can reduce, and -60 over 40. So that's -1/2, -3/2. So that right there is our projection of U onto V. Now we need to do where W2 is equivalent to U minus my projection of U onto V. So we've got 4, -3, which is U, minus my projection, -1/2, -3/2, which minus negative, it's actually going to be end up added together. So then you've got, what is that? 9/2, and -3 plus 1.5, so that's 3/2, and it's a -3/2, and that's our projection, or that's W2, which is U minus the projection, sorry. W2. Last step is we need to write them as the sum of orthogonal vectors. So we can say that U is equivalent to my W1, which is the projection, those are identical, -1/2, -3/2, plus my W2, which is 9/2, and then -3 over 2. Okay, and that's the answer. So the reason why this says projection with a direction opposite V is that one is negative and one is positive. So the projection of U onto V is parallel to V. They aren't going to have the same direction as one is facing the positive and one's facing the negative direction, in which you can see that in our outcomes, that we've got those negatives in there. So that's what it's looking at, because V is positive, but if you look at the projection, it's a negative. So that's where we're looking at. Remember, the negative determines the way the arrow faces, not necessarily a negative length, because we can't determine that.